Hello everyone. Today let's solve the problem number 417, Pacific Atlantic water flow. So what the question states here, so we are given a grid of heights. So we have been given a grid of heights. Let's come to the example part here. You can clearly see here. We are given a grid of heights basically. We have to find all the cells where water can flow to both this one, Pacific Ocean as well as the Atlantic Ocean. So they have clearly mentioned here. Just give me a second. So here we have to find all the cells where water can flow to Pacific Ocean as well as the Atlantic Ocean. That's what they have given here, right? So the Pacific Ocean means top and left edges. So see here, top and left edges, right? So this one they're speaking of top and left edges, Pacific Ocean, and the Atlantic Ocean, bottom and right edges, bottom and right edges, right? So here too, basically this part they are speaking of. So given a grid of heights, we have to find all the cells where water can flow to both Pacific Ocean as well as the Atlantic Ocean, right? So water can flow from a cell to adjacent cell. So again I'm telling this one, just listen to this very carefully. Water can flow from cell to adjacent cells up, down, left or right only if the adjacent height is less than or equal to the current cell's height. Means here in this case, suppose we are considering 4 here. Water can flow to Pacific Ocean only if the adjacent cell's height is lesser. So here it can flow to Pacific. See here, 4, suppose we are considering left here. 4 is 2 is less than 4, it will flow here. So it can flow to Pacific Ocean here, right? Same goes with the Atlantic Ocean. We have to check for Pacific as well as the Atlantic Ocean. See, if we consider top, then also it is fine. 2 is less than 4. Again, we'll check whether 2 is less than 4. Yes, 2 is less than 4. It will flow to Pacific Ocean. We have already seen this one. So let's check for Atlantic. So we'll check down. So here 7 is less than 4. No, this miserably fails here. So let's check for the next cell here. We'll check for 5. Whether 5 is less than 4. No, 5 is not less than 4. Here it fails. It will not flow to Atlantic Ocean. It will only flow to Pacific Ocean accordingly with the requirement, right? So I hope this is completely clear, easy to understand, right? So water can flow from the cell to adjacent cells either up, down, left or right only if the adjacent cell's height is less than or equal to the current cell's height, right? This is the condition. I'll show you for the one more cell so that we don't get confused when we discuss the approach, right? See here, let's consider this one, or let's consider 5 here. In this case we have already considered for the thing which doesn't flow to the Atlantic Ocean, right? So here let's consider 5 here. In this case 3 is less than 5, so we can move forward. 2 is also less than 5, we can move forward here in this case. So it will flow to Pacific Ocean, this 5. So 5 here, let's consider left basically either. So we have already checked for Pacific Ocean. It will 5 will flow to the Pacific Ocean, right? Next let's check for the Atlantic Ocean. Down we can check here for 1. So 1 is 1 less than 5. Yes, 1 is less than 5. Next cell is 1 less than 5 again. Yeah, 1 is less than 5. So it will flow to Atlantic Ocean as well. I mean it 5 does flow to the Atlantic Ocean and Pacific Ocean both. So this cell we have to consider in the output. We don't have to consider the value 5. We have to consider the cell. Basically this is 0, 0, 1, 0, 2, 0, right? Here 2, 0, 2, 1, 2, 2. So this one 2, 2 we need to return in the form of output. This is one of the cells which matches the condition. We have to find all the cells that matches the condition basically, right? So 2, 2 is one of the cell that matches the requirement that they have given in the question, right? So this is how we need to check for each cell basically. Don't get confused, right? So easy to understand, right? They have clearly mentioned in the question, and we know now what to do basically. We know now what to do. We have to return all the coordinates from which water can flow to both the oceans. So that's what they have given. And one more thing I want to say here, this cell, the bottom left cell and the top right cell, this one, this cell and this cell I'm speaking of, this we can consider directly because you can clearly see here, this part I am telling, this directly flows into Pacific and Atlantic Ocean. right? So here you can clearly see this edge I am speaking of, bottom left and the top right, this one as well, right? So this directly flows into the Pacific as well as the Atlantic Ocean. Top right and bottom left, we can always we can consider this one, right? So this one will be 4,0 and this one will be basically 0,4. These two cells directly flows into the Pacific as well as the Atlantic Ocean. So we can consider them directly. Which one? 4,0 and 0,4 in this case. So for any example, it goes with the same thing. Top right as well as the bottom left cell. This we can consider directly. It flows into the Atlantic as well as the Pacific Ocean directly. Just keep this in mind. This is very important, right? So yeah, this is it, right? They have given another example. We have only one this thing, one, right? 0, 0. The water can flow from the only one cell to the Pacific and Atlantic Ocean. It is the leftmost cell. It can, right? So we don't have any cell to compare at all. So we have only one cell. So water can flow from only one cell to the Pacific as well as the Atlantic Ocean. Nothing but 0, 0. Coordinates we have to return in the form of output, right? So simple, right? So I hope the question is completely clear. What we need to do is completely clear as well, right? I hope the question is completely clear. What we need to do is completely clear as well. I'll just consider the same first example and let's discuss which are the cells that can flow into Pacific as well as the Atlantic Ocean, right? So we'll discuss that one and then let's discuss the approach followed by edge cases one by one and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the first example. So let's discuss the first example first, right? So here I'll only show you the cells which can flow both into Pacific Ocean as well as the Atlantic Ocean. So you can just check for the other cells which fails as well, which either flows to Pacific or the Atlantic, which will not flow to both Pacific as well as the Atlantic Ocean. You can just check for other cells as well. I'll show, again I'm telling, I'll show you only the cells which flows into both Pacific as well as the Atlantic Ocean, right? So first thing I've already said, this top right as well as the bottom left, these cells directly we can consider because this one flows to the Pacific as well as the Atlantic Ocean directly because these are present at the edges, right? So this one we can consider directly. So here I can just consider 0, 4 and 4, 0 here in this case, right? 0, 4 and 4, 0 in this case, right? So here, what are the other cells basically? What are the other cells? So here I'll show you the cells which satisfy the condition accordingly with the question, right? So we have considered 5, this one and this one, right? So these cells we have already considered. So let's come to the 4 here, 4, right? So here in this case, let's check whether this flows to Pacific Ocean or not. So let's check with this cell up. So whether 3 is less than 4, yes, 3 is less than 4. So it will flow to the Pacific Ocean. This is fine. So next, what is the condition? Basically, the cell which is adjacent, either up, left, right or down. So that cell's value has to be less or equal to the value that we are considering currently, right? So this one, let's check whether this can flow to the Atlantic Ocean as well. So see here, let's consider the right one. So yes, whether 4 is less than or equal to 4, yes, 4 is less than or equal to 4. So this can flow into the Atlantic Ocean as well. So we will consider this cell as well. So here in this case, this is 1, 3, right? Let's come to the mid one. So here we have 5. So let's check for the Pacific Ocean. So here up I'll consider first, right? So you can consider left as well. This satisfies both actually. So up, 3 is less than 5. Yes, 3 is less than 5. Next, let's move one more step, right? So up itself. So whether 2 is less than 5, we'll check whether 2 is less than 5. Yes, 2 is less than 5. So this will flow to Pacific Ocean, right? This will flow to Pacific Ocean. So next, let's check right, or you can check down as well here in this case. I'll go with the right. So it satisfies both here. I'll check whether 3 is less than 5. Yes, 3 is less than 5. Let's move to the next cell, one step ahead. So again, 1 is less than 5. Yes, 1 is less than 5. This will flow to the Pacific Ocean, Atlantic Ocean as well. So we will consider this cell 2, 2 here in this case, right? So let me come to the part, this one, 7. right? 7. So here let's check whether this flows to the Pacific Ocean. I'll consider left side here. 6 is less than 7. Yes, 6 is less than 7. So this will flow to the Pacific Ocean. Let's check for the Atlantic Ocean. Basically, let's check down here. 1. 1 is less than 7. Yes, 1 is less than 7. So this flows to Atlantic Ocean as well. So we will consider the cell here, coordinates 3, 1. So just give me a second. What happened here? Sorry. So this has to be basically 3, 1, right? This has to be basically 3, 1. This 7, right? So this flows into this one, Atlantic as well as the Pacific Ocean as well, right? So here we got all the cells. One more cell here, we'll consider 6 as well here. 6, so it is next to adjacent to the Pacific Ocean. Yes, this will flow to the Pacific Ocean. Let's check for the Atlantic Ocean as well. You can clearly see here, this down, let's consider here. So 5 is less than 6. Yes, 5 is less than 6 basically. So it can flow to the Atlantic Ocean as well. We'll consider this one as well, 3, 0. These are the cells basically meets the requirement accordingly with the question, right? So we have already considered these coordinates. We need to return in the form of order. Doesn't matter basically. These are the coordinates that are present in the that satisfy the condition accordingly with the question, right? So 0, 4, 4, 0, 1, 3, 2, 2, 3, 1 and 3, 0. These are the cells which can flow both into Pacific Ocean as well as the Atlantic Ocean accordingly with the requirement, right, or the condition that they have given in the question, right? So I hope this is completely clear, easy to understand, right? Simple. So now what shall we do? Let's discuss the approach, right? Let's discuss the approach, and let's discuss the approach first. So let me come here. So now let's go with the step-by-step execution here. We will start BFS from the Pacific border cells. Top row plus left column first. Top row, this one. Top row, left column, this one we are speaking of, right? So here in this case, we'll start the BFS from Pacific order cells, top row plus left column. We will start the BFS from Atlantic border cells, bottom row, right column. Bottom row, right column means this one. Bottom row, right column, this one we are speaking of. Bottom row, last row, right column means the last one. The last one, the first one and last one. So we will start the basically, just give me a second here. We have considered the same first example right here. We'll start the BFS from Pacific order cells, top row plus left column, and we'll start the BFS from Atlantic border cells, bottom row plus right column, right? So let's move on to the step 2. Now we have we completely know about the step 1. Let's move on with the step 2 here. For both Pacific and Atlantic, we have to simulate the reverse flow, right? We have to simulate reverse flow. So water can reach a cell from the ocean if height is increasing or equal. Height is increasing or equal means the cell next to it, horizontally or vertically, whatever we are considering, left, right, up or down, the value what we are considering, the value has to be greater than the value that is present in the left, right, up or down. That's what we saw, right? We have already discussed this one. We know this one, right? So water can reach a cell from the ocean if height is increasing or equal. So we move ocean from oceans inward, checking if the neighboring cell's height is correct. This is fine, right? So this theory you don't have to actually completely know. When we write the code, you'll understand this one, right, clearly. So intersection part here. After BFS, cells marked reachable from both oceans that are collected. Basically, after performing BFS here, the cells that are marked reachable from both oceans are collected. In our case, what were the cells basically? These are the cells basically: 0, 4, 4, 0, 1, 3, 2, 2, 3, 1 and 3, 0. Just give me a second here. So yeah, these are the cells: 1, 3, 2, 2, 3, 1 and 3, 0. These are the cells basically. So this is the output that we got. So which is equivalent to the output that they have given for the question 1 here. So here you can clearly see 0, 4, 1, 3, 1, 4, 2, 2, 3, 0, 3, 1 and 4, 0. So let's check here. 0, 4 is present here. In this case we got 0, 4 here. This is fine. So the next one here is, sorry, just give me a second. Next one here is 1, 3, whether 1, 3 is present here. So here this is present 1, 3, right? So 1, 4 is present. Yes, 1, 4 is present somewhere. So I didn't include 1, 4 here. Sorry, this one I forgot, I think. So in this case, so this cell basically I forgot here. See here, let's compare this one as well. Let's check whether this flows into the this one. What do we call Atlantic Ocean? First, see here, this is adjacent to the Atlantic Ocean itself, so it can directly flow into the Pacific. This one, Atlantic Ocean. So let's check for the Pacific Ocean as well. So up there is a value 5, which is greater, so it fails. So down there is a value 1, but next to 1 we have 5. This fails as well. So let's check left. So we'll go with 4 here. 4 is less than or equal to 4. Yes, 4 is equal to 4. So next let's move to the left side. So 3 is less than 4. Yes, 3 is less than 4. We are considering for the cell 1, 4, right? 3 is less than 4. Next let's come to the next left cell. One step. So 2 is less than 4. Yes, 2 is less than 4. Next let's move one more step left here. 1, 0 means 3. 3 is less than 4. Yes, 3 is less than 4. So next let's move to the Pacific Ocean. Yes, it can flow to the both Pacific as well as the Atlantic Ocean. We have to consider 1, 4 as well. I forgot this one, right? So let's add this one here. 1, 4 is present in the output. We have got 1, 4 as well here. In this case we have got 1, 4 as well. These three we got. Let's check for 2, 2 here in this case. So 2, 2 here it is there, right? So 2, 2 is present in our answer as well, in the output that we got. So let's check for 3, 0. So here 3, 0 is there. 3, 0 is also present, right? So this is fine. Let's go with the 3, 1 and 4, 0. So here in this case 3, 1 and 4, 0. So see, all the cells that we got here, the answer that we got is equivalent to the answer that they have given for the question. I mean example 1 in the question. So approach works absolutely correct, right? Same cells here, whatever the cells they have mentioned, the same cells that we got as answer, right? The output that we got is equivalent to the output that they have mentioned for the example 1 in the question, right? So the approach works absolutely correct in this case. So now we are completely familiar with the approach. As we are completely familiar with the approach, let's discuss this one edge cases one by one, right? So the first edge case is for the only one cell. Only one cell. We are having only one cell here. So the output will be 0, 0. This we have already discussed in the question. Second example, right? Second example, if you remember. Only one cell. So let's move on with the second edge case here. Increasing left to right. So we have 1, 2 and 3. So we have 1, 2 and 3. 0, 2, 0, 1, 0, 2. This is the only cell which can flow into this one. Output is 0, 2 here, right? So this is the only cell which can flow into both the Pacific as well as the Atlantic Ocean, right? Let's move on with the third edge case here. So in this case, decreasing top to bottom. So here 5, 4 and 3 we have 0, 0 is the output. So I can just check in the same way that I had showed for the that I showed by considering the first example, right? Let's move on with the final edge case or the plateau or the fourth edge case, this one plateau, right? Heights we have here as 2, 2, 2, 2, right? So output is here 0, 0, 0, 1, 0, 1, 0 and 1, 1. So I can just if you want to know how we got the output, you can just draw this one within the cells. You can just give the value and just check in the same way that I showed for the example 1. It will be easier to understand. I insist you to check so that you understand this problem better, right? So these are the 4 edge cases that we need to keep in mind. First one is for only one cell. The second one is for increasing left to right. The third one is for decreasing top to bottom, and the fourth one is for plateau, right? So these are the 4 edge cases that we need to keep in mind. Now we are completely familiar with the approach as well as the edge cases. Now we are completely familiar with the approach as well as edge cases, right? As we are familiar with the edge cases and approach, we are good to write the code. Let's start writing the. So the first step here, let's get the number of rows and columns first. So I'll just type this one quickly. Int rows equals height dot length here, and columns, we'll just consider calls here. Heights we are consider or height. So heights is the parameter, right? So let me make this one heights basically. Dot length. Oh, so this is for the columns, right? So I'll just come here. Just give me a second. Let me mention 0 within the square braces. So this is. So the next step here is we have to go with the matrix to track cells reachable from Pacific as well as the Atlantic. So let's write these two lines quickly here in this case. So we are going with the Boolean value, right? So this is for the Pacific, and this will be new Boolean of, we are considering rows as well as the columns. So let me copy the same thing and make the necessary changes for Atlantic here in this case. So here instead of the Pacific here, let me delete this one. I'll just make this one Atlantic. This is fine. So here we are considering the matrix to track the cells that is reachable from both Pacific as well as the Atlantic. I'm speaking of the line number 5 and 6. Easy to understand, right? So this is fine. So the next step is we will be going with the BFS. We have discussed this one in the approach, that we'll be going with the BFS as well as the Q. BFS plus Q, right? So here, let me give Q here. So let's make use of the BFS Q for Pacific as well as the Atlantic. So here in this case, let me give Q. So let me do one thing here. So let me give here, sorry, what's happening here? Int. So this is fine. So this was the Pacific question, right? Pacific Q. I'll just go with new linked list here. So this is BFS Q for Pacific. Let me copy the same thing and make necessary changes for this one, Atlantic as well. So let me come here. Instead of Pacific here, let me give Atlantic. This is fine. This is for Atlantic Q. So this is BFS Q for Atlantic, right? So let's let's move on with the next step. Let's go with the iteration, right? So we have to check for each cell. So I'll just go with int I equals 0, I less than rows. Basically, we have to do the same thing with the columns as well. First, let's do it for the rows, and next, let's do it for the columns. So I'll just go with plus here. So iterative approach here. So first, what we have to do, let's consider the left edge that touches the Pacific, right? So if you remember, the left edge that touches the Pacific basically. So I can just write it in this way. Pacific, as we are going with the Q, we are going level by level, right? BFS. We are not going with the DFS. Don't get confused. We are going with the BFS basically. So it can be, this can be solved by DFS as well. So basically BFS is the choice, perfect choice for this problem. These kind of problems should be solved by BFS basically. This problem is meant to be solved by BFS basically. So here I'll just give new int. So I'll do one thing here. So did I miss something? No, right? So we are considering the left edge that touches the Pacific. So this will be I comma 0, index comma 0. This is fine. We should consider the right edge as well. Along with the left edge, we have to consider the right edge that touches the Atlantic as well, right? So I'll just copy the same thing and make the necessary changes here in this case. So instead of Pacific, let me make this, let me do one thing. Let me copy this one instead. So I'll just go with Atlantic Q. So offer, as I'm making use of the offer property because we are adding, right? We are adding this one to the Q, right? Pole for removing, offer for adding basically. So this one new int of instead of I, this will be I itself. Instead of 0, this will be false minus 1. This is fine. this is the line number. What does line number 12 and 13 do? Basically, we are considering left edge and the right edge that touches Pacific and the Atlantic. Line number 12 and 13. Simple. So the next step here is we have to mark the Pacific Ocean, Pacific that is reachable, means the coordinates that is reachable to the Pacific, as well as we have to mark the Atlantic reachable. Both we have to mark, right? So I'll just write here in this case. So let me write it here itself. So we are writing this one within the same for loop, right? This is for the rows basically. We are not for the columns also. We have to do the same thing. Before this one, let me write this one. So here in this case, Pacific of I comma 0. Let me initialize this one too. Means we are marking the Pacific reachable, and next we have to mark the this one Atlantic reachable as well. Let me copy the same thing here. Let me paste it over here. Instead, where is Atlantic? This one. Let me copy this one here. In this case, I'll just make this one to Atlantic. Right? Instead of this one 0, it should be columns minus 1, as we are going for the dealing with the Atlantic basically. So this one also will set this one to true. We are marking Pacific reachable as well as the Atlantic reachable, right? So we have went with the rows now. Now let's do the same thing for the columns as well. Let me copy the same thing and make the necessary changes here. So from this one, line number 11 to line number 16. So here, let me paste the same thing here, right? So let me do one thing. Let me format this one once. Here, this has to be for, let me change the variable name here. This will be j equals 0. So this one has to be j less than columns, right? So this one we have already considered for rows. This one will be column. So let's increment the j here. This is fine. So the next step is we have to add the top edge that touches the Pacific and the bottom edge that touches the Atlantic. Basically, we are speaking of top right edge and the bottom left edge, which touches the Pacific and Atlantic, right? So here, this will be same thing, Pacific Q dot offer. So here new int, this is same thing. Instead of we are not considering rows, columns we are considering, right? Here this will be 0 comma j, right? So this is the top edge that touches the Pacific, and next line, this is the bottom edge that touches the Atlantic. Basically this will be rows minus 1, and instead of this one will be j, as we are dealing with the column. So let me delete this one, just give me a second. Yeah, this is fine. So the line number 21, Pacific of I comma 0 we have considered. This is for the rows basically. This for the columns it will be 0 and j, right? We are setting this one to the true. We are marking Pacific that is reachable, and we are marking this one Atlantic that is reachable here. Instead of I columns minus 1, as we are dealing with the columns here, in this case it will be rows minus 1, and this will be j instead of columns minus 1. So let me delete this one quickly. So this will be j. This we are setting this one to true. Previously we did for rows here from line number 11 to 16. Here from the line number 18 to 23 we are doing it for the column. Same thing. We just change certain things, right? So this is fine. The next step after this one is we have to perform BFS for Pacific as well as the Atlantic, right? So we have to perform the BFS for Pacific as well as the Atlantic. So let me come out of this one and let me do one thing here. Just give me a second here. BFS here, this one. So before performing the BFS for Pacific as well as the Atlantic, let's consider let's take the helper function BFS. This is a helper function BFS we are considering. We haven't written anything within the helper function, right? So let's write the helper function and perform the BFS, and then let's make use of this one in the main function. Within the main function means this one basically, Pacific Atlantic function, right? So I'll just come here. Let's quickly consider this one. What do we call? Helper function. So I'll just give here private void BFS, and so parameter heights we have boolean, I'll just consider visited as parameter as well as, so let's go with the q here in this case, int. So this one will be q. So did I miss anything here? So yeah, this one I have to close this one, right? So let me go with the parameter q here. This is fine. So within the BFS function, let me initialize the rows as well as columns. Rows equals height dot length, columns equals this one, HTS heights 0 dot length. This is fine. The next step is we have to explore 4 directions. One is right, left, down and up, right? So we have to explore 4 directions: up, down, left and right. So let me quickly write this one. Simple, right? Pure BFS. So just give me a second here. Directions here in this case. So let me go with right first, 0, 1. Then let's go with left here, 0, -1. Then let's go with down here. For down it is 1, 0. And then let's go with up here, nothing but -1, 0. So this is fine. We have to explore the 4 directions. So we are initializing directions. This one, assigning directions to the value. So next, so q shouldn't be empty to proceed further, right? So let me to perform BFS, q shouldn't be empty. So we'll check while q is empty. So this is fine. So then we have to get the current cell. First thing, int, let me give here cell equals q dot poll. We are removing, so I'll just make use of the poll property. Means we are getting the current cell here. After getting the current cell, we have to move to the neighbor row as well as the neighbor column. For that one, I'll just make use of the simple for loop here. Int, let me go with d of directions, right? Every direction we have to check, right? So here we have to move to the neighbor row as well as the neighbor column, just for the checking purpose. So I'll just give here nr equals cell of 0. We have considered for the individual d, right, within the directions, within the for loop. So I'll just give here d of 0. Same thing, I'll copy this one. So let me paste it over and make the necessary changes. So this is for the neighbor row. This is for the neighbor column. So neighbor column, I'll just make this one to the NC here. So this one will be cell 1 and this one will be d of 1. This is fine. So just give me a second here. So d of 1. So this is fine. So after moving to the neighbor row and neighbor cell, what we have to do? We have to check for the bounds. Means whether it is out of bounds or whether it is not visited, and height condition as well. We have to check for the height condition as well. Height condition means the value that we are considering should be greater than the this one, horizontal cells or the vertical cells that we are considering. The value of the horizontal cells or the vertical cells that we are considering by performing the DFS, that we need to consider as well. We are checking whether it is out of bounds, not visited, and height condition, these 3. So let's write the simple if condition very quickly. So neighboring row, if it is greater than or equal to 0, and neighboring column, nothing but NC here in this case, greater than or equal to 0, and we will consider NR less than rows here, and we will consider NC neighboring column less than columns here, and just give me a second, it's place here, this is fine, and we are going with when not visited. If not visited of neighboring row as well as neighboring column. So and we have to consider the height condition as well, right? So I'll just go with here, and this one will be heights of neighboring row as well as neighboring column, NR NC here, whether this is greater than or equal to heights cell 0, this is fine, and cell 1 for the neighboring column, right? So this one we are considering, this one, right? Cell 0 and cell 0 we have already considered for the row, cell and 1, this one for the column basically. So then what we need to do here, this is simple if condition, right? Let me open the if condition. So we have to mark visited, means we have already visited. So this one I'll just give here visited of neighboring row, neighboring column. If already visited, then we have to give true, boolean value true, and then we have to add that particular this one to the queue, particular coordinates, or the, what do you call that one? Yeah, coordinates itself. We have to add that one to the queue, right? So I'll just give here queue dot offer. Adding will make use of offer, for removing will make use of poll, right? So let's go with the offer here. So new int, so what we have to add, nr comma nc, neighboring row, neighboring column. So this is it for the BFS basically. This is it for the BFS. Let me format the code once, right? Let me format the code once. So now let's come to the main function. So we have to perform the BFS for Pacific and Atlantic. That's where we left, right here. So this one I'm speaking of, line number 24. So this has to be BFS of heights, where we have already written the helper function BFS. Now we can include the same thing within the main functions. So BFS of heights, Pacific as well as the Pacific queue, right? So let me copy Pacific and Pacific queue from somewhere, man. So Pacific queue, let me copy from this one. I don't want to this one type basically, and Pacific as well. Pacific somewhere I mentioned. Where is Pacific? Yeah, this one. So here line number 24. Yeah, this one. Let me paste it over here. This is fine. So let me copy the entire line and make the necessary changes for Atlantic as well. So here what we are doing, line number 24 and 25, we are performing BFS for Pacific as well as the Atlantic, right? This is for heights, Pacific. Instead of Pacific, we have to go with the Atlantic. So let me go with Atlantic here. Let me copy this Atlantic here. So let me change this one to Atlantic. Instead of the Pacific queue, we have to go with the Atlantic queue. Let me copy this one and paste it over here. This is fine. So after performing the BFS for Pacific as well as the Atlantic, so we have to store the cells that reach both the oceans, the final step, right? So we have come to the final part here. So let me do one thing here. Just give me a second. So this is lagging, very laggy. So this is fine. We have to store the cells that reach both the oceans, Atlantic as well as the Pacific. We have come to the last part. So I'll just go with the list. We'll be making use of the array list. So I'll just go with list here. Type integer. So this one, we do one thing. Yeah, let me make use of the variable name result. Let's create the array list here. Array list. So this is fine. So the next step here is let's iterate through the rows and columns. So here int r equals 0, r less than rows. Let's increment the r here. This is fine. Let's go with the columns as well. So here this will be c equals 0, c less than column. So let's increment the c here. This is fine. So if it is reachable, means from both the oceans, means if we get if the particular coordinates or the particular condition, I mean particular value that we considered, if it can flow to both Atlantic as well as the Pacific, means if it is reachable from both oceans, then we have to add that particular coordinate to the result, right? So that's what, right? Let's write the simple if condition here. If let's go with the Pacific. Somewhere I mentioned Pacific. Let me this one. If Pacific of r c, this one, and Atlantic. So this one, let me copy the same thing here. Atlantic of r c, this one, if it is reachable, then we have to add that one to the result. Let me make use of add property itself here. Result dot add. We are making we are adding that one to the result, right? So I'll just go with arrays dot as list, right? So what we are adding here, r comma c, simple to understand, right? So if it is reachable from both the oceans, then we are adding this one to the result. Final step is we have to return the final list. So here what the solution we got, we have to return the final list, right? So final list means we have to return the result. Basically we have considered the variable name as a result, right? So we have to return the final list, nothing but in this case return result. So this is it for the code. So might be little bit lengthier but easy to understand, right, if you go step by step. So this is we have successfully written the code. So let me format the code once and let me hit the run button. So here we have error. Let's check what is the error first. So here we have incompatible type boolean cannot be converted to the boolean. So again line number 5, 6 we have same thing. So just give me a second, and array required but boolean found. Line number 14. Let's check for line number 5 and 6. So yeah, here we have to mention one more square bracket, right? So this is why we are getting the error basically. So let me hit the run button again. Hope this is resolved. This gets resolved. So yeah, let's come to line number 28 now. So somewhere we have error. Here what error we have? Let. So again JavaScript with Java. So I get confused. So I'll just make this one to int here instead of let. So we are checking for the row right here. Or this is something else after the BFS, right? This one, yeah, int I have to give here. Again I have given int here. This is fine. Yeah, let me hit the run button. I get confused with the JavaScript basically. Again one more error we have. So I have misspelled rows here in the line number 48. So let me remove 1w here. So let me hit the run button again. One more error we have. What do we have here? Variable rows incompatible type int. You're getting, cannot find the symbol and the like. So basically we have initialized the rows right here. So let's check. Just give me a second. Oh yeah, I have misspelled the rows here. Let me remove I here. So many types. So here let me hit the run button again. I hope this works. Now what we have? So incompatible types int cannot be converted to int height. So which line we have? So let's check what we have done wrong. So here I have misplaced the bracket, I think. So this has to be, oh, cell and 0 I have given differently. This has to be cell 0. Yeah, same goes with this one as well actually. Cell of 1. So this one I have to close here. It's fine. Now this has to fine. This should be fine now. Let's see. So yeah, now we can clearly see the sample test cases are getting passed. So I had misplaced brackets here on this line number 50. This is fine. So let me hit the submit button quickly. I hope it works for all the test cases. Let's see. So yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written, right? So the approach that we went with here is BFS or reverse BFS from ocean borders, right? So you can just call this one as reverse BFS or BFS. So what would be the time complexity here? The overall time complexity would be big of m into n. Why it is big of m into n here? Because each cell is processed at most twice, right? Once for each ocean. So this is for once for this one Atlantic Ocean and once for this one Pacific Ocean, right? So overall time complexity would be big of m into n. So what would be the space complexity here? The overall space complexity would be big of m into n as well. So why it is big of m into n? Because we are making use of the two visited matrices, right, which is of size m into n. Also we are making use of queues and result list as well. So overall space complexity would lead to big of m into n, right? So the time complexity and the space complexity is big of m into n for the code that we have written. I hope the complexities are, and hope whatever the code that we have written is completely clear as well, right? For now, that's it. Thanks for watching, guys.